for another lecture. In this lecture, we're going to talk about the geometry of circle. We all know what circle is. One of the things about circle is if we have the center of the circle, we call that any distance from the center of the circle to edge of the circle, that's our radius. And if that radius continue all the way to the other side from one end of the side of the circle to the other side, we call that diameter, and diameter is equal to time radius. We know that. And another thing you want to know is if you have a two line intersecting the side of the circle, like this one here, and we can call that, let's bring that here, that's the chord of the circle. Then if we have something like this line right here, this blue line, we call this an arc. And we're going to do a couple of problems to kind of get familiarized with these terms and how we're going to measure the interior angle. When you have a circle like this, you can put all kind of a shape in it, especially triangle, and we can use those to our advantage. To have this problem and we want to find out what is the angle of B is, if we take a look at the theorem which I have on a board. So when we have a condition that the inscribed angle of the circle is an angle whose vertex is a point which is located on a circle and whose sides are the chord of the circle, and this is our condition, and therefore the theorem says the measurement of that angle is half of the measured of the inscribed angle. So in this case, our angle is basically 1/2 of 58 degree, which comes out to 29 degree. All right, let's go to another problem. All right, so we're looking at this problem right here, and we have Pn is equal ON. So we gotta this triangle is a quadrilateral triangle. That means all angles are equal. So that means each angles are 60 degree. We know that. Okay, and then it says find QP. Well, before we do that, this is incredible. These two lines crossing each other, making a bunch of triangle, and we can take this to our advantage. So now we have this triangle, and then we have this big right angle triangle also. Let me kind of mark that over with a pink. We also have this triangle formed by it. Okay, and we were trying to find out this distance QP, and there was some stuff we learned earlier. Take a look what's on the board, and from there we can go ahead and say, okay, because these we know all these angles become 60 degree, and therefore OP is equal PQ, and all these three lengths are equal, and measurement angle 1, and we have this angle right here, this angle 1. Let me write that in different color. We have angle 1 and 2 right here, and we have angle 3 right here. So angle 2 we know is equal 60 degree, and so is all these three. Now, when you look at this is a supplementary, right? If this is a 60, so that's going to be 180 minus 60. So angle 1 is equal 180 minus 60, so that gives us 120 degree. And now we have that. We look at, so that's 120 degree, and this is these two legs are equal because the way it's crossing each other. So that means these two angles are equal. So 120 minus 180, 180 minus 120, that will give us 60. And 60 divided by 2, it gives us 30 degree. So this angle 3 is equal 30 degree. And take a look at the thing we have on a board. So if you have opposite angle 60, it become what? And therefore we can say, okay, Pn time square root of 3, which was 12 square root of 3. And that's our answer, whatever comes out to. Okay, let me erase this. We go to the next problem. Okay, take a look at this problem here. We have this shape here, and we want to find out these angles, but what been given is the arc of, only thing been given to us the arc of AB, which is about 92 degree, and arc of DA, which is from here to here, and that's 114, and arc BC 138, B from to C, and this arc is 138. What does it mean by when we have these arcs? Let me just draw a small circle here. Wow, that's pretty good. If I have something like that and I have this angle going right here, and if this arc right here, say, is 60 degree, and this is 60 degree right here, this is 60 degree, providing this is at the center. So we're going to take a look at that, and we're going to take a look at these to our advantage. So now we're going to come back here. We have everything. We got from point A, let's go over around a circle all the way. We have C to B, we have B to A, we have A to D. Oh, we don't have D to C. Let's find out D to C. So I'm going to say arc of DC, and that's equal, let's go different color here. So that's going to be 360 minus 92 and 114 and 138. So basically we're going to take all these and deduct it from that, and 360 to find out what that comes out to, equal to 16 degree. So now we have that. That makes it easier. And then take a look at the theorem, and it says angle of 1. So angle 1 is this angle here, and it's like previous problem we talked about based on that theorem. It's this is the vertex, and this is the arc for it right here, creates this arc. So that's 16. So angle 1, it comes out to 1/2 of MDC, which is 16. And that comes out to 8 degree. Okay, now we're going to go to angle 2. Angle 2 is ABD. I had to write this down and rewrite this. So angle ABD, that's A right here, that's B right here. So this two line, AB, this is the one right here. So it's this line right here. Okay, and the theorem says since your vertex is on over here, and your angle, your arc is right here, and the arc came out to AB, came out to 92, and therefore your angle 2, it's going to be half of that. So that's equal 1/2 of 92, and that's degree. All right, let's look at angle 3 now. Angle 3 is AFB. There's A, there's F, there's B. And the theorem says this is outside of the circle. Because it's outside the circle, 3 is equal 1/2 of 1/2 of 92 minus 16, and that is 38 degree. Angle number 4 is DEC. There is D, there is EC. So we're talking about right this here, DEC. Okay, so the vertex, it's going to have angle number 4. I need some room here. We say M4 is equal 1/2 of those two combination, which is 92 plus 16. And that comes out to 54 degree. Angle number 5. This is, we can do this two different ways. One is angle number 5, which is the angle CEB. CEB. This angle we're looking at right here. This angle right here, CEB. So we know angle 4 already. And that's a straight line supplementary. We can say, okay, 180 minus angle 4. So angle number 5, it's going to be 180 minus 4. 4 was 54. 54, and yeah, 126 degree. So that's going to become 1/2 of 38 plus 114. 138 plus 114, and that should come out the same number. That's it.